Right. Well, why don't you tell us you are majoring in computer engineering and want to be a computer engineer. So distinguish that from all the other fields of engineering.
Okay, yeah. Uh, I wanted to be an engineer since I was pretty young. Um, my family, I've always been that sort of person where, your mom or dad comes to you and says, "Hey, my phone's broken. Can you fix this?" Or, "Hey, the TV's not working. Fix that." And so I
Hmm.
always knew that I liked to work with computers. So I knew I wanted to do something with that. And through playing games and sports, I developed a sort of competitiveness and a desire to win. And through playing board games or video games or something, I developed a love for puzzles and solving puzzles. And so computer engineering is a great mix between working with computers and problem solving and solving those types of puzzles. So computer engineering, to answer your question, is well, let's start with engineering. Engineering is basically where it's a team of people who take science and they take what scientists have figured out, and then they take that knowledge and create something with it. That's what engineers do. They create things. And so mechanical engineers, they would create things such as an engine in your car, or they would work in a paper mill down the street, or they would create the gears that work in a tractor on the farms that produce collect your food. An electrical engineer works with electricity, and so they would do something like working with buildings and running the electricity through the building, or working on the power line and running the electricity all throughout the city. And computer engineering is very similar to that. However, it's at a smaller scale. So instead of running electricity through buildings and through cities, through power lines, computer engineering works with the small chips inside of your computer or your phone. Like take your iPhone, for example. There's a small chip inside of there, a mini computer that sorts information and multiplies and adds, and then it stores that information, and then that's how a phone or computer works, and that's what a computer engineer does.
All right, I love that. Great metaphors with the puzzle, and everyone I know loves to have someone in the family who is like the tech person. I don't know if that's what they call you, but it's so nice
Yep.
to have people to be like, "Oh yeah, here." For me, it's Jason, and he's the tech guy around here. So, um, all right, so let's talk about like I think people kind of get like inside the phone. So like when you're in class. Are you gonna have, is the chip gonna be on a computer and then how does that part work?
Yeah, sure. During class, there's computer engineering, like I was saying, was is basically working with the chips inside of your phone.
Mm-hmm.
Um, but the basis of computer engineering, like I was saying before, is very similar to electrical engineering. So I've learned and I've taken a bunch of electrical engineering classes to develop that base and that foundation for what I'm going to be learning in the future. One of my classes called Intro to Logic Design was talking about gates, and it's like logic gates. So if, for example, an and gate means that if you have this and this, then it means yes. But if you don't have both of them, then the output would be no or zero. And so we learned about that, and we learned about how we can use those different types of gates to control and sort information coming in to a device and going out of a device. And so in that class, we were working with this thing called an FPGA development board. I'm going to try to pull up a picture, but
Oh,
that's what an FPGA development board does. And so in my intro level classes, this chip right here is what. Well, first I'll explain what FPGA means. FPGA is an acronym and it stands for Field Programmable Gate Array. And
okay.
basically, it's saying that this chip can do a bunch of math and you can program it to do whatever math you need it to. And that's
Okay.
really all a computer is. It's just this it's a chip that does a bunch of math and stores and sorts information. And so in FPGA, this is a very common field in computer engineering where basically you have one of these boards. And if you're testing something, like if let's say you work for Apple and you're developing a new chip, right? Before Apple sends that request to a manufacturer and produces a bunch of chips, which costs millions of dollars, they would test it on a device like this to make sure that it runs appropriately. Because this board, although it might not be the most efficient, it's programmable to whatever your needs are, and you can test different products or test different code to see if it would work. And so in that class, in the class called Intro to Logic Design, we programmed these boards to produce an output. Some boards have uh, like
Oh,
little
wow.
numbers on them, like this,
Okay. And
like
like,
this
how
one.
big is that board? Like, would that be as big as a table or like less than a foot?
That
Okay.
board is less than a foot, maybe about
Wow.
uh, 4 inches, like I'd
Wow.
say like maybe 6, 8 inches. So
Wow.
it's a pretty small board, yeah.
So there's like a bazillion details going with this one board.
Yes.
Okay.
Yeah, so there's a lot of different components, but the nice thing about this is that you don't have to use all of them. If I'm just testing something that to run a clock, let's say I'm making a clock and I'm trying the company, let's say the company I work for or the professor that I'm working with says I need a project that, we're building this machine and all the electrical needs to do is run a clock. Then I can take this board and then program a clock and see if it works using just this part right here. But if I need it to do something more advanced, then I can use more features on the board to test that as well.
Okay. Wow. So you worked on this board. Was it a team in the class or it was just you with this board, or was it different people working on, like you said, maybe you'd work on the clock. Would there be three other people working on other little parts of it?
Yeah, so in this class specifically, because it was the intro level class, each individual student had their own board, which is very nice that we had the resources to do that. And we
Hmm.
were working on just the clock. And basically, if we pushed a certain order of buttons, these buttons over here on this side, if we push the buttons in a certain order, then the clock would display a certain image. And so that was one of our projects. And so it's very simple, but it was a good foundational
Hmm.
project, and we got to do that by ourselves.
All right. Well, I'm glad you think it's simple. To me, it sounds beyond anything I've ever known. Um, but that is cool, and thank you for the graphics. Um, all right. So I have to think because I think a lot of people might struggle being able to do this kind of work. I imagine the job, like they need a lot of you, I'm guessing.
Yeah, there's a huge demand for engineers in general nowadays.
Mm-hmm.
If you like to learn, um, anyone who with a desire for continuous learning would be great in engineering because it's a challenging field, but with the challenging aspect of the industry, there also comes a lot of rewarding
Mm-hmm.
features to it as well. So the nice thing about engineering, especially computer engineering, is that Apple is producing a new product every single year, or Microsoft or Google, they're creating something new every single year. Every other month they're coming out with something new, and it's a very fast-paced field, which is something I find interesting about it.
Yeah.
And I really like that fast-paced, challenging, competitive aspect to computer engineering. And so, yeah, they're looking for a lot of new engineers. Computer engineering is specifically like the hardware side of things, and then there's also software engineering, which is similar to my field, is the programming type of things, where you're programming different type of software, and I don't know, you could write a website, you could
Okay.
program a website, or you can program a video game, and there's lots of different aspects of software engineering as well. And yeah, there's a huge demand for different types of engineers.
Wow. So this question just came to me. We're at what, like iPhone 17? Is that the newest that people actually have? So how
Yeah, the
many
17
people,
is the
oh God.
newest.
Okay. So how many people do you think are working on the 18? I mean, you might not know, but like a guess. And are people
If I
working
were to
on 19
guess,
and 20 already?
oh yeah, I would assume that so the Apple releases a new phone about once a year, usually in September or October. And so if I were to guess, there's probably a few hundred people working on an iPhone, maybe a few thousand. I know the way that they do it is that they have a small team of people working on every single part. So just the charging port, there could be 5 to 20 people working on just the charging port. And then there could be, 20 people working on the cameras and 5, 10 people working on how to connect the cameras to the motherboard, which communicates to everything else in the device. So um,
Mm.
each engineer, when it comes to a device like an iPhone, they're not working on necessarily the whole thing, but you're working on a little part and you're trusting in each other enough to where you work on your part as well as you can and to the best of your ability, and then you trust your fellow engineers to make sure that their part is also well, and then when you connect them all together, it'll work.
Wow.
So similar to an iPhone at school, I'm on a rocketry team, and it might not
Mm.
seem similar because iPhone is, something that you hold in your hand. It is a rocket is something that you launch into the space. But with my rocketry team at school, we have a bunch of different types of engineers. We have computer engineers and electrical engineers working on the computers inside of the rocket that send a radio signal to the ground, which we collect the data from the rocket. So that's what I do. But then we also have mechanical engineers who work on the shape of the rocket and try to optimize the dimensions to make sure our rocket flies as smoothly as possible and as high as possible. Um, we have different mechanical engineers working on what the size of the fins are and how big to make the fins. We have a new team this year that we're adding called the air brakes team. And the air brakes team, that basically we were adding these brakes to the rocket. Um, and I'm not too sure how they work. I'm trusting in those other engineers to make sure that they get done right. But from my understanding, the air brakes team is designing these brakes that will be able to automatically control the height or the apogee of the rocket while it's already in the air, so that we have less moving factors that we have to predict while or before we launch the rocket. And those air brakes should be able to automatically control the height of how high we launch the rocket, which is really cool.
Wow. So I'm just guessing, like, if people were really into the rockets and things, they would maybe want to work for space, like
Yeah.
NASA. Okay.
Yeah. So, with my experience with my school's rocketry team, I'm looking into working for an aerospace company such as Boeing or Airbus. They're the two big manufacturers of airplanes. So if you've ever flown
Oh,
on
okay.
Delta or American Airlines, Boeing and
Right.
Airbus make the airplanes. I could also go into Lockheed Martin or NASA, somewhere that makes spaceships, right?
Yeah.
So I could be an engineer, like a computer engineer, could be working on the control systems that collect data or send data or receive data from a rocket or a airplane. And so, an
Mhm.
engineer could be working on sending a guy to the moon. So you might not be the astronaut, but you could be the reason the astronaut gets there, which is really cool.
Right. Yeah, that is very cool. And so the rocketry team, this is not a class. You are, it's kind of like your extracurricular, and you guys meet and do these special
Hmm.
things. And you're
Yes.
going to get us
So
a video later when you launch it.
yes, yeah, we actually just launched our rocket. I believe it was in the end of June, maybe early July, we launched our rocket. So I'll get that to you. And
Go
we
ahead.
launched our rocket at the end of June, maybe early July. And the competition was in Midland, Texas, which is
Mm,
really cool. It's middle of nowhere, Texas, where there's a bunch of desert and it gives us a lot of room to launch rockets. Our rocketry team competes in this competition against around 140 other schools in the world. So
wow.
schools from all around the world, like Australia or Africa or Europe or South America, like Brazil, will come to Texas and we'll all compete against each other, see who has the best rocket. Um,
Wow.
and my school's team placed 18th out of around 140 schools this past year. And so, yeah, I can get you a video of that. It's pretty neat. We've got some pretty cool videos of the manufacturing, and we've got cool videos of the actual launch. So I'll definitely get that your way.
Yeah, that's great. Um, so you kind of touched on this, but in 10 years, your ideal, tell us, I think I know what you're going to say, but in 10 years, where would be your ideal spot that you're working and using this degree? Would it be as would you be called a computer engineer or would it actually be a different job title?
Yeah. Depending on the company you work for, a computer engineer could have different job titles. If you work for a smaller company, computer engineer could be, your job title, but you're working on a broad range of things, a wide range of things. You could be working on control systems for like a large office building where you flip this switch and then this half of the building shuts off, or you flip this switch. So you could be working on control systems like that, or you could be working for a large company like Boeing, like I mentioned before, where they build airplanes and they have lots of different engineers working on the same plane. And so they would have a more specific title, such as an avionics engineer or a systems
Oh,
engineer.
all
And
right.
avionics basically means the electrical or the computer work for an airplane or any aerospace system. So my title for Liberty Rocketry's team is avionics flight computer engineer. And
Okay.
so it's a little more specific, but yeah.
All right. And later I'm going to look up how to spell avionics because I'd never heard that word before. I love it. So you would want one of those roles.
Yeah. So I
Oh,
would love to work on some sort of avionics team. I think radio frequency would be really cool. Radios, it's not just magic, it's actually a bunch of math that goes into how a radio works.
okay.
Um, I was listening to during the summer, I work as a groundskeeper and I continue to try to learn while I'm working. It's kind of a monotonous task. And so while I'm, doing my work, I listen to podcasts. And I was listening to a podcast the other day about this new company called Teradar. Basically, it's a radar company, but they're producing radar frequencies that's like such a high frequency where it's your phone. Apple has this thing on the back of the camera. It's called a LiDAR sensor. And that's how if you take your phone and you go to the Measure app, you can take your camera and choose one spot and then choose another spot, and it'll tell you it's about 18 inches or it's about 3 feet or
Hmm.
something. So that uses a LiDAR sensor, and it's basically just a bunch of uh, radio waves that are at a really high frequency, meaning they're sent and received at a really fast rate.
Hmm.
And so that would produce like a high definition signal, and radar like a radar scanner or something that you had seen in a radio control tower for airplanes that sends a lower frequency, but that would allow the signals to get a further distance and to be able to go through weather. And so this podcast that I was listening to. Sorry, it's a little nerdy, but
It's
they were
okay.
talking about this company called Teradar, and basically, they're producing these radar signals at a frequency between the two that I just talked about, and it allows for the high definition of lidar, but also the distance and um, yeah, distance of regular radar, which I thought was really neat.
Yeah. I mean, things I'd never even heard of LiDAR before. And now I know I can measure with my phone. Someone actually just asked me to do some measuring in their kitchen, and I'm going to see if I can use the LiDAR thing. So,
Yeah, it's pretty neat.
very cool. So you talked a little bit about your childhood and like your you could always fix things and do puzzles and stuff like that. What would you tell kids who would maybe want to go into this field, like things you wish you'd done or things you're glad that you did when you were in elementary, middle, and high school?
Yeah, I would if a kid was interested and they came to me asking about how I am taking steps to get into this industry, I would tell them that to stay as involved and as active as possible. I feel although there's not a huge connection from some of the things I did in elementary school, I would recommend. I was really big into sports. It's not necessary, but sports taught me a lot about working together as a team, especially with people you might not see eye to eye with, and it taught you how to problem solve with them. And like football, for example, not everyone on the football team saw a problem the same way, but we all worked and gave our all to try to achieve the same end goal, which was winning the game. And so that's kind of like engineering. It's not the exact same because sports is a lot more physical, and I'll probably be sitting at an office. But
Hmm.
taught me a lot about working with other people. I also in middle school I was in this club called Makerspace where the teacher brought in a lot of donated old electronics and we were or different devices such as like a toaster or something. And yeah, they weren't working anymore, but we were allowed to just have fun and go at it. And we unscrewed toasters or unscrewed a printer or something, and we would try to
Hmm.
figure out how it worked. And I thought that was really fun.
Yeah. One of my kids loves like building and putting things together, so I should probably give her my old appliances and see what she can do. However, I have to ask, did anything ever get blown up or anything, or when you guys were working on this stuff?
No,
Okay.
yeah, the teacher tried to remind us not to stick any forks in the
Oh,
outlets or anything.
oh my gosh, that's great.
Yeah, I would just say that there's like I think we did mention it before, but there are lots of different types of engineering.
Hmm.
And so I think, you might not want to build an airplane, but you could work on a car. And if you think cars are really cool and you want to figure out how that works, if you're a curious individual, I think it's worth a shot to look into and
Hmm.
try to figure that out because I've seen a lot of cool videos about someone who, might not have enjoyed math that much, but they loved to problem solve and they ended up becoming an engineer, pushing through the math, and now they work for like Mercedes or something and they design really cool
Hmm.
sports cars. And so, I just say keep an open mind, and there's a huge demand for engineers. It's a really fun and challenging but rewarding field, and yeah, I think it's really neat. I enjoy it.
Yeah. I'm assuming you were in all the advanced math and science in high school.
Yeah, so in high school, I ended up getting through AP Calc 2, and I also took AP Stats. Um,
Oh,
Not
wow.
necessary. If you go to college, they'll let you, you'll start with Calc 1, but because I did AP, I was able to start with Calc 3, so that lightened up my course load a little bit. I'm still graduating on time. I'm not graduating early or anything.
Okay.
So it's given me some more time to work with extracurriculars, which is really nice. I get to devote more of my time to that.
Yeah.
But yeah, even if you're not, even if you don't go super far in math in high school, you can still be an engineer and you work through calculus starting from the bottom at college, and you learn. You devote a lot of time to that, and yeah,
Hmm.
one day be an engineer.
Yeah. Um, what is the highest level of calc one can take?
There is the highest level of calc is Calc 3 that's required for engineers. I believe some schools offer Calc 4, but that
Okay.
might be the same thing as differential equations. I just finished that class,
Okay.
which was really fun. Um,
What's been the hardest class you've ever had?
the hardest class I've ever had was, I think it was, I would say advanced C++, which is it's a programming class, and C++, before I don't really want to get too in depth into it, but for software engineering, there's a bunch of different programming languages, and it's like saying English or German or Spanish. They're all different languages, and certain languages are better at others at some things than others. So C++ is better at like processing quickly, but it's not as easy to program. And Python's easier to program, but it doesn't run as fast. And so C++ was one of the foundational courses that they had us take, and the advanced class was very difficult. It took a lot of time to work through those labs.
I
Yeah.
bet. Yeah. Oh, goodness. All right. Um, all right. Well, I'll hit stop recording.